Chapter 1, Section 4, Introduction to Matrix. In this video, I provide you with a brief overview of a critical concepts of linear algebra, matrix. What is matrix? Simply put, a matrix is a two-dimensional array of numbers arranged in rows and columns. Each number in a matrix is called an element or an entry. We can identify each element by its row number and column number, usually written as a pair in that order. Let's consider a matrix A. We could describe it in this way. In this matrix, each small letter A followed by two digits represents a single element. The first digit after A indicates the row, and the second digit indicates the column of that element. So, A11 is the element in the first row and the first column. A23 is the second row and the third column, and so on. As we will see later, using matrices, we can represent and operate linear equations in compact and organized ways. Matrices can have any number of rows and columns. We call the number of rows and columns the dimensions of the matrix. A matrix with m rows and m columns is called an m by n matrix. For instance, let's consider a matrix B. This matrix has 3 rows and 2 columns, so we say it's a 3 by 2 matrix. We can perform several basic operations of matrices, such as addition, subtraction, and multiplication. First, let's see how to implement matrix addition. Addition should be performed element-wise, which means that the matrices must have the same dimensions for addition to be possible. For instance, if we have two 2 by 2 matrices A and B, the sum A plus B is a new 2 by 2 matrix, where each element is the sum of the corresponding elements in A and B. For example, suppose we have the matrix C and D, consisting of these elements. If we add these matrices, we can obtain this matrix. Similarly, matrix subtraction should be done element-wise. The matrices must have the same dimensions for subtraction to be possible. For instance, if we have two 2 by 2 matrices, A and B, the difference between A minus B is a new 2 by 2 matrix, where each element is the difference between the corresponding elements in A and B. For example, suppose we have the matrix C and D consisting of these elements. If we subtract matrix D from matrix C, we can obtain this matrix. Next, let's go on to multiplication. We can perform two types of multiplication: scalar multiplication and matrix multiplication. In scalar multiplication, we multiply every element in the matrix by a scalar, a single number. Suppose we multiply matrix A by the scalar k. In that case, every element of A is multiplied by k to produce a new matrix. For instance, suppose we have this matrix C and a scalar k which equals 2. In this case, we can perform scalar multiplication in this way and obtain this matrix. Matrix multiplication is a little more complicated operation. To multiply two matrices, the number of columns in the first matrix must equal the number of rows in the second. If we multiply an m by n matrix by an n by p matrix, the result will be an m by p matrix. To multiply matrices, we need to follow these steps. First, check that the number of columns in the first matrix equals the number of rows in the second matrix. If not, the multiplication is not possible. If this condition is satisfied, multiply each row of the first matrix by each column of the second matrix, using the dot product formula. This will give you one element of the resulting matrix. Repeat this process for all rows and columns to get the full resulting matrix. For example, suppose we have matrices A and B here. We can multiply them in this way and obtain this new matrix. Now that we've covered the basics of a matrix and some primary operations, let's discuss some special types of matrices with unique properties that are particularly important in linear algebra. Here, we will cover the square, identity, diagonal, and symmetric matrices. First, let me explain square matrix. A square matrix is a matrix that has the same number of rows and columns. For example, a 2 by 2 matrix is a square matrix. It is because both the number of rows and the number of columns are 2. On the other hand, a 2 by 3 matrix is not a square matrix because the number of rows and the number of columns are different. Next is identity matrix. It is always denoted as I. Identity matrix is a square matrix with ones on the main diagonal and zeros everywhere else. Here, the main diagonal means the elements from the top left to the bottom right of the matrix. For example, this is the 2 by 2 identity matrix. The next one is a 3 by 3 identity matrix. A notable feature of the identity matrix is that when it multiplies any matrix, the result is the original matrix. This property holds whether an identity matrix is multiplied with another matrix from the left or the right. Next, let's see a diagonal matrix. A diagonal matrix is a square matrix in which elements of the main diagonal can either be 0 or non-zero, and the elements outside the main diagonal are all 0. An identity matrix is a kind of diagonal matrix. But a diagonal matrix is not necessarily an identity matrix because in a diagonal matrix, the elements on the main diagonal can have any value, including 0. And because in a diagonal matrix, any value can appear on the main diagonal, not just ones. For example, this matrix C is a 2 by 2 diagonal matrix. And this matrix D is a 3 by 3 diagonal matrix. Finally, let's see symmetric matrix. A symmetric matrix is a square matrix that is equal to its transpose. The superscript T attached to the capital letter A denotes the transpose matrix of matrix A. A transpose matrix is obtained by flipping the matrix over its main diagonal, turning its rows into columns, and vice versa. For example, this matrix B is a symmetric matrix. As we can see, it is equal to its transpose. On the other hand, this matrix C is not a symmetric matrix because its transpose is not equal to the original. There are many more special types of matrices, such as orthogonal matrices, triangular matrices, and so on. Later in this course, we will explore these matrices in detail. Thank you for watching. Please thumbs up and subscribe to my channel.